Module 9, Homework 3, Systems of Linear Equations and Two Variables. Now, I find that a lot of people have seen this before, but I am going to pretend like you've never seen it, so we're all on the same page. So everything we've been talking about previously with Module 9 is talking about one line. So now, what if we have two lines? So a systems of linear equations is just two lines. And our solution to two lines is just going to be the point where they cross. It's going to be our point of intersection. So our answer is going to be the ordered pair x comma y. So our answer is an ordered pair. So we have two lines. Our answer is the ordered pair, and it's the point of intersection, the point where these two lines cross. So we have different scenarios. We could have one solution, meaning if I have two lines that could cross in one point, that one point would be our answer, whatever this x comma y is, that would be our answer. Whenever we're solving this algebraically, that would give us like x equals some number. Once we find x, we can plug that in to find y, all that good stuff. So one answer. Our other type of solution could be no solution. What if there are two lines that never cross? What's another word for two lines that never cross? Parallel. So if there are two lines that never cross, they're parallel lines, and that means they're never going to cross, so we're not going to have a solution. So no solution. And that would give us, if we're solving it algebraically, a false statement. So something like -6 equals 3. -6 does not equal 3. It's a false statement, so that would tell us no solution. Our last scenario is what if these two lines are laying right on top of each other? Their answer is the point where they intersect. Well, they intersect, they touch at every single point. So that means we have infinite solutions. So every point on the line is a solution. If we're solving this algebraically, we would get a true statement. So something like 3 equals 3, that's true. So because it's true, our answer would be infinite solutions. The solutions go on forever. It's two lines on top of each other. So those are our three different scenarios that we're going to see. We're going to go through all three of them as we go through these examples. So consider the following graph of systems of equations. Remember, the systems of equations is just two lines. So if we have two lines, remember our answer is the point where they cross. So what point do these two lines cross at? Perfect. -2, -4. They both cross right here. That ordered pair, that x comma y. On our x value, we're going over to -2. On our y-axis, we're going down to -4. So -2, -4 is going to be our answer. We're going to write it as ordered pair like that. That is our answer. That's it. So on the next page, we're actually going to solve this. On the test, on the homework, you're going to have three different ways of solving it. And it's going to tell you. So do it the way that it wants you to do it. Because you have to do it all three ways. And they tell you the easiest way. So listen to what they say. So we're going to solve by graphing. We're going to solve by substitution. And we're going to solve by elimination. So three different ways to solve these things. We're going to do all three methods together. Before I go to the next page, questions on this one, please. All right, so if no questions, let's do the first one. So our first thing says solve by graphing. This example is straight from the homework. It says solve the systems of equations by graphing 2y minus 2x equals 12, -12, and y plus 2x equals 6. So we're going to graph both lines on the same graph right here. And we're going to see the point where they cross is going to be our answer. So first dealing with 2x minus 2y. I said that wrong. 2y minus 2x equals -12. I really hope I get my brain back in April, whenever she comes out. It is killing me. All right. I'm like really trying to focus too to not mess you guys up. Just do what I'm writing. Don't listen to what I'm saying. Just don't listen. Just write what I'm saying. All right. So 2y minus 2x equals negative 12. So I want to put this into y equals mx plus b form so we can find the slope, find the y-intercept, and graph it. So put into y equals mx plus b. We're just graphing two lines. Remember, we graphed lines back in test 1. So going back to test 1. So think about it as a good thing. I know like these aren't really fun. I get it. But think about it as your study final because you're going back to what we did on test 1. So let's get y by itself. So if we have 2y minus 2x, let's move that negative 2x to the other side. Let's add 2x to both sides. That way negative 2x plus 2x cancels out. We're left over with 2y equals 2x minus 12. 2y equals 2x minus 12. Almost done. Now just getting y by itself, it's 2 times y. So we can divide both sides by 2. That way the 2's cancel out. Both terms, remember, are being divided by 2. So we're left over with y equals 2x over 2 minus 12 over 2, which will simplify down to y equals x minus 6. So now it's in y equals mx plus b form. So we can look at it and say, okay, our m value, which is in front of x, in this case, it's going to be positive 1. So our slope, which is our m, is positive 1. I could rewrite this as positive 1 over positive 1 because I know my slope is going to be rise over run. It's positive 1, so I know I'm going to go up 1. It's positive 1 on the bottom, so I'm going to go to the right 1. Rise is up and down, positive is going up. Run is left and right, positive is going to the right. And we also know our y-intercept is the ordered pair 0, b. Here our b value is negative 6. So our y-intercept is going to be the ordered pair 0, negative 6. This is the only point that I have so far. So this is going to be my starting. That's in my starting point. So starting at over 0 down to negative 6. 0, negative 6, that's going to be our starting point. And from that 0, negative 6 starting point, I can use my slope to find another point. So my slope says from this point, go up 1, right 1. And I can keep going because I'm not very good at drawing lines. So I'm going to keep going to give us some more points. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So that's enough. Sorry, I got a little carried away. So connecting my dots. Now it should be easy to draw a line because I went crazy. There's my line. So that was all just for that first line. So now do the same thing for the next line. So our next line is y plus 2x equals 6. So again, I want to put it into y equals mx plus b form. So I'm going to get y by itself. So let's move that 2x to the other side. So we can subtract 2x from both sides. That way those cancel. So y equals negative 2x plus 6. So now that's in y equals mx plus b form. So just by looking at it, we know our slope is going to be negative 2, and our b value is going to be positive 6. So our slope for which is m, is -2. If you want to write it as -2/1, go for it. I know my slope is rise over run. So if I'm rising -2, rise means going up and down. Negative means I'm going to go down 2. And I'm running +1. Run is going left and right. Positive is going to the right 1. So down 2, right 1. But we're going down 2, right 1 from where? We need to have our starting point. So let's get our y-intercept, which we know is the ordered pair 0, b. So in this case, our b is +6. So our starting point is going to be at 0, +6. So 0, +6. So starting there at 0, 6. So once we start at 0, +6, I can use my slope to find another point. My slope says from that point, go down 2, right 1. 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 Boom, they cross right there. So let's connect the dots. Oops. There's my 2 lines. So my answer is the point where they cross. What order pair did they cross at? Thank you. 4, -2. So that's going to be our answer. Our answer is going to be 4, -2. Our answer is the point where the lines cross. So all that for this one. One more like this, then we'll go into substitution. The next one's not as long. This is our longest one. So thankfully, the next one is already in y = mx + b form for us. So solve this system of equations by graphing. Y = -1/2 x + 3 and y = -1/2 x + 2. So first dealing with y = -1/2 x + 3. It's already in y = mx + b form for us. So we can see that our slope is -1/2 and our b value is +3. So our y-intercept is the ordered pair 0, b. So in this case, our b is +3. So our starting point is at 0, 3. Over 0, up 3. We're going to start there. And then just by looking at this, our slope, which is our m value, is -1/2. So -1/2. I put that negative up top just to kind of help me, because I know slope is rise over run. I'm rising -1, so that means I'm going to go down 1. I'm running +2, so I'm going to go right 2. So from my starting point, from 0, 3, I'm going to go down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. That's enough. Connecting the dots. Done with the first line. So same thing for the second line. Our second line is y = -1/2 x + 2. Again, this is in y = mx + b form for us. So we can see our m is -1/2 again, and our b is +2. So our y-intercept is going to be the ordered pair 0, b, which we said b was +2. So our y-intercept is going to be at 0, positive 2. This is our starting point. So over 0 up 2. And then our slope is going to be -1/2 again. So -1 is our rise. So we're going to go down 1. And our run is +1. So to the right 2. So from our starting point, from that 0, 2, we're going to go down 1, right 2. Down 1, right 2. Down 1, right 2. Down 1, right 2. What do you notice? They're parallel. They don't have the same slope, which, by the way, if you've seen that in the beginning, that's cool. But they have the same slope, so parallel. So if they're parallel, that means they're never going to cross. So what's our answer? No solution. No solution. They're the same slope, so they're going to be parallel lines. That means they're never going to cross, so that means no solution. So that is all by graphing. And we're going to do solving by substitution next. Before we go there, questions on this one. I know my lines aren't that good, but whatever, you get this point. Questions on this one? So a few more seconds if you're still copying. If you have a question, please let me know. If not, we'll go to the next page. All right, so that's solving by graphing. The next method that we're going to do is solving by substitution. So solve the system of equations by substitution. So that means here I have two lines. Lines have two variables, x and y. We need to find what x equals and what y equals. So I can't solve for it whenever I have two variables, but what I could do is substitute one variable into the other equation. So for example, here I have y equals -4x and -4x minus 3y equals -16. So it's telling me that y is the same thing as saying -4x. So for this other equation, instead of y, I can substitute where I can plug in -4x. Then I'll only have x's, so I can solve for x. So I have -4x minus 3 times y. We know y is the same thing as saying -4x equals -16. So we plugged the y equals into the other equation. And now we're going to solve for x. We're going to get x equals. So it told us y equals -4x. So instead of y, we're going to plug in -4x. So let's solve this. So -4x, -3 times -4x is +12x equals -16. Combining like terms, -4x plus 12x will give us 8x equals negative 16. Getting x by itself, it's 8 times x. So we can divide both sides by 8. And we're left over with x equals negative 16 divided by 8, which is negative 2. I'm halfway done. I found what x equals. Now that I know that x equals negative 2, I can plug that back into either equation to find y equals. Doesn't matter. This first equation looks easier, so let's use that one. So if we know y equals negative 4x, we know x is negative 2, so y equals negative 4 times negative 2, which is y equals positive 8. That's your answer. So putting it as an ordered pair, remember our ordered pair is x comma y, so x is negative 2, y is positive 8. Done. We solved it. Way better than graphing. So we're going to do one more with this one. We have 1 minute to do 3 problems, so that's why I'm going fast. Questions on this one before we go to the next one? All right, let's do one more like it. So same exact problem, solved by substitution. X minus 4y equals negative 37, and negative 2x plus y equals 11. So this one doesn't give us x equals or y equals, but we can solve it in either equation. So this first equation, we could either do x equals, because x is kind of by itself, or in the second equation, y is kind of by itself, so we can do y equals. Which one doesn't matter, it's going to give us the same answer. First one, I think that's what you said. So x minus 4y equals negative 37. Let's solve for x. Let's get x equals. So that means we can move that negative 4y to the other side. So adding 4y to both sides. That will give us x equals negative 37 plus 4y. X equals negative 37 plus 4y. Okay, great. So now that I know that x equals, I could take that and plug it into my other equation. So now we're going to plug into equation. Our other equation was negative 2x plus y equals 11. Hello? Hello? Yeah, can you call me back in like 10 minutes? Is everything okay? Okay, I've already talked to someone about that, so I should be good to go. Okay. No, I gotta go, so I'll call you back. Sorry, it was a filter. I was making sure everything was fine. It's about money. That's all they wanted. Sorry. All right, so it scared me though. So negative 2x plus y equals 11. So getting, we know that x equals negative 37 plus 4y. So I can plug that in for x equals. So negative 2. Instead of x equals, I can plug in negative 37 plus 4y plus y equals 11. So negative 2, instead of x, I can plug in negative 37 plus 4y plus y equals 11. So here, instead of x, we're plugging in what we found x was, negative 37 plus 4y. So now I only have y's, so now we can solve for y. Oh, that's so aggravating. Sorry. All right, so let's distribute. So -2 times -37. And that will give us +74. -2 times 4y will give us -8y plus y equals 11. Combining our y's, -4, -8 plus 1 will give us -7y equals 11. Getting y by itself, we could subtract 74 from both sides. So -7y equals 11 minus 74, which is -63. And then getting y by itself, -7 times y, so I can divide both sides by -7. And we're left over with y equals 9. So I got y equals. I can plug that into either one to find x equals. X is kind of by itself on this first one, so let's use this first one. So x minus 4y equals -37. We know y is going to be +9. So x minus 4 times 9 equals -37. -4 times 9 is -36. So x minus 36 equals -37. And then last but not least, adding 36 to both sides, those cancel. We're left over with x equals -37 plus 36, which is -1. We did it. We found x and we found y. So x is -1, y is 9. Our answer is the ordered pair -1, 9. And that's it. We have two more examples, which these elimination is the fastest, I think. So these will go by the fastest. But I know it's past time. So if you need to go, you're welcome to walk out. I'm going to stay recording to do these last two problems. It shouldn't take us very long at all, especially that last problem will take us 2 seconds. But before I go there, questions on this one? Questions on this one? Done? All right, so elimination is the last method. So before we substituted x equals or y equals to only get one variable. Now what we're going to do is we're going to eliminate one variable whenever we add the two lines together. So if we had to solve by elimination, -3x minus 5y equals -9, and -4x plus 2y equals 14. So just by looking at this, if I add these two lines together, x isn't going to cancel, y is not going to cancel. But if I had, let's say, -10y and +10y, I chose y's because one's already positive, one's already negative, then those would cancel. -10y plus 10y would cancel out, they would eliminate. So let's make this first one -10y. In order to make this -5 into a -10, I need to multiply everything by 2. So everything on both sides of the equation by +2. That will give us -6x minus 10y equals -18. I'm choosing, it's my choice, you could choose to eliminate x. I'm choosing to eliminate y. I chose to eliminate y because one's already positive, one's negative. So I just need to make those numbers the same, kind of like LCD. So same thing on the bottom. I want the bottom to be +10y. So that means I need to multiply everything by +5. So that'll leave us with -20x plus 10y equals 5 times 14, which is 70. So now whenever I add these two equations together, -10y plus 10y eliminate. They cancel out. So we're just left over with x's. So if we add them, -6x minus 20x will leave us with -26x equals -18 plus 70, which is 52. So negative 26x equals 52. Getting x by itself, I can divide both sides by negative 26. And we get x equals negative 2. So we found x equals negative 2. Just like we did with substitution, now that I know that x is negative 2, I could plug it into either equation, the first one or the second one, doesn't matter, and I can find what y equals. So let's go for it. Which equation do you like better, the first one or the second one? They're both kind of ugly. First one, okay. So if we have negative 3x minus 5y equals negative 9, I'm going to plug in x is negative 2. So negative 3 times negative 2 minus 5y equals negative 9. Negative 3 times negative 2 is positive 6. Minus 5y equals negative 9. I could subtract 6 from both sides to get y by itself. So negative 5y equals negative 15. Negative 9 minus 6 is negative 15. And then getting y by itself, we could divide both sides by negative 5. That way we have y equals negative 15 divided by negative 5, which is positive 3. Boom, there's our answer. We have x, which is negative 2, comma y, which is positive 3. Done. So that's solving using elimination. We have one more, and we're done with this whole packet. I was trying to put the whole problem in one page. All right, so last one, solve by elimination. If we have 4x plus 2y equals negative 28, and negative 12x minus 6y equals 84. Your choice, do you want to eliminate x or y? They're both equally, one's positive, one's negative, they're both the same. Y. All right, so if we want to eliminate y, this y is negative 6, this y is positive 2. I can multiply this first equation by positive 3, and that way it would be positive 6y and negative 6y, and they would eliminate. So this first equation, I have 3 times 4x, which is 12x, 3 times 2y, which is plus 6y, equals negative 3 times 28, which is 84. The bottom equation's already negative 6y, so I don't have to touch it. It's already good to go. Negative 12x minus 6y equals positive 84. So our whole point here was to eliminate the y's. So negative 6y minus 6y's do eliminate. Let's see what we're left over with. 12x minus 12x will give us what? 0. Negative 84 plus 84 will give us 0. So everything canceled. 0 equals 0. True statement. So remember whenever we went back to that first page, if we said it was a true statement, like 3 equals 3 or 0 equals 0, our answer was infinite solutions. So our answer is going to be infinite solutions. On the homework, it'll give you the option of like multiple choice, kind of like where the first choice you could plug in a point, second choice would be no solution, third choice would be infinite solutions. Remember, if it was a false statement, so for example, like 3 equals 5, that's a false statement, so no solution. Thank you very much for staying over, but we did it. We finished test 4 notes packet.